Section 8.2 is multiplying and factoring. I can multiply a monomial by a polynomial, and I can factor a monomial from a polynomial. Big ideas here. A monomial can be multiplied by a polynomial using the distributive property. Factoring a polynomial reverses the multiplication process. And the first step when factoring a monomial from a polynomial is finding the greatest common factor of the terms of the polynomial. In example 1, we're going to be multiplying a monomial and a trinomial. So we want the simpler form here of this product. We're going to distribute here. Anytime we have multiplication outside our parentheses, we're going to take that into everything inside if we can't reduce inside our parentheses, which we can't here. So I'm going to take negative x cubed times each of the terms inside my polynomial. So times 9x to the fourth. We take the sign with the number, so times negative 2x cubed and times a positive 7. When I do this, remember the negative is like a negative 1. So we're going to take our number parts, negative 1 times 9 to get negative 9. And when I multiply my powers with the same base here, I keep my base, add my exponent. So 3 plus 4 is 7. Here I take a negative 1 times a negative 2 plus 2, and I add my exponents after I keep my base. So 3 plus 3 is 6, and negative 1 times 7, negative 7, and here I just have x cubed. Last thing we want to do is make sure there's nothing we can combine as far as like terms go, and to make sure it's in standard form. And here we are. So we're going to distribute very similarly to how we've done it before. The only difference is now we're distributing variables as well, which we haven't done before. That's the new part. So instead of just distributing a 2, we're going to distribute a variable as well. Feel free to pause here and give this a try if you'd like. We're going to take our 5n times everything inside our parentheses. Because we're multiplying, in order to get rid of my parentheses, I have to distribute and multiply all the way through. So I'm going to take 5n times 3n cubed. And then I'm going to take, since it's a positive 5n times negative n squared. Again, that sign goes with the number. And then I'm going to take 5n times the 8. So again, I took my 5n times all three terms inside my parentheses. Now when I simplify, 5 times 3 is 15. Remember that n is to the first power, so I keep my base, add my exponents. 1 plus 3 gives me 4. Here, we also have a 1 as our coefficient there. If there's not a number shown, our coefficient is a 1. So here it's a negative 1 times 5, which gives me a minus 5. Keep my base, add my exponents as long as my bases are the same. So since they're both n's, I can take 1 plus 2 to get 3. Here I take my number parts. 5 times 8 is 40, and then times my variable there, just n. Double check, we can't combine anything here because my variables aren't exactly the same. They're different degrees, n to the fourth, n cubed, n to the first. And they're in standard form, which means our highest degree to our lowest, in descending order there. In example 2, we're going to find the greatest common factor here of our terms. So here we have three terms. We have a 5x cubed, 25x squared, and a 45x. So in order to find our greatest common factor, we need to have each of our terms in factored form. So we want to break them down to their prime pieces. 5 just is a 5. So I'm going to make a 5 column here. And then I have 3 x's. So I'm going to write those out. X, x, and x. That's one row. Now 25, factor tree here is 5 times 5. So its prime factors are 5 times x squared, or x times x. I'm going to put a 5 underneath my 5 and make a column of 5s here. My second 5 I don't have a column for, so I'm just going to make one. Now I have 2 x's here, x squared, so I'm going to put those in my columns that I already have created here with an x. Keep in mind that each polynomial gets its own row. Now 45 is 9 times 5, and 9 is 3 times 3. So a 5 I'm going to put in my 5 column, and again I'm going to start in the middle and work my way out. 3s I don't have columns for, so I'm going to make 3 columns. Okay, again, it's like if these were labeled, this column would be a 3 column, this column would be a 3 column, this column would be a 5, an X, and an X column. Okay, if those were my labels. And we don't know what those are going to be until we start getting our prime factors. Keep in mind we only list our prime factors, so I'm not going to put the 9 over there. Okay, I only list the prime ones, only the things at the end of our branches. I also have an X here, so I'm going to make sure to put that in my columns. So, real quick double check, 5x cubed, perfect. 5 times 5, 25, x squared, perfect. 3 times 3 is 9, times 5 is 45x, wonderful. So all of our columns, check, or all of our rows, check. Now we compare our columns. Any columns that are completely full, 5 and x's. We multiply those columns together, and that's our greatest common factor. So here, 5x is our greatest common factor. Some of you may have looked at these and said, well, I know I can take a 5 out of all 3 of these because my leading coefficient is a 5. And I know I can take an x because my last term has an x in it. And realized it there. That's great. Go for it. But we're not always necessarily going to recognize the greatest common factor right away. We'll see our common factors, but not always pick out the greatest one there, and we always want to have our greatest. So this is a kind of a foolproof way of doing it as long as you break down our numbers right. If you want to just kind of glance at them and check, go for it, but we might not always get everything. Here 5 is prime, so it's fairly easy to pick out, but when we start getting into more complex numbers, there's chances that we'll miss things. Feel free to pause here and give this a try if you'd like. What is the greatest common factor of these terms? Well, again, 3 is prime, so I don't have to break that down at all. And then I have x to the 4th power, which means I take my base, x, times itself 4 times. 9, I can break down as 3 times 3. And don't forget we have this negative. That's like a negative 1 times 9. So 3 I'm going to put in my 3 column. And then I have to make a new column for 3's. And I'm going to make a column for negative 1's. X squared. X and x. And again, I start from the middle and work my way out with my numbers and with my variables to make sure that I'm filling columns if I can. Next, 12. 4 times 3, which is 2 times 2. We can break down that however we want. We could have done 2 times 6 as well. It doesn't matter. Also remember that we have a negative 1 times that. So I'm going to put a 3 in my 3 columns. I don't have 2 columns, so I'm going to make a couple columns for 2's. And then I'm going to put a negative 1 in my negative 1 column and an x. So when I look here for my common factors, I have a 3 in everything and an x in everything. So my greatest common factor is 3x. We multiply those together to get our greatest common factor. If you look here, the negative 1 was in 2 of my factors, but not in all of them, just like this extra x here. So I can only take them out if they're in every single column. If it's a full column, then it's one of our factors in our greatest common factor. In example 3, we're going to be factoring out a monomial. So we're going to write this in factored form. What they're asking us to do, guys, is to take our greatest common factor and factor that monomial out. But we still need to have what's left. So factored form, remember factors are things we multiplied together, means we're going to have 2 things multiplied in our final answer. So here I'm going to break down my 4 as 2 times 2. And I have 5 x's, x to the 5th power. 24, I'm going to break down 12 times 2, 2 times 6, and 2 times 3. Doesn't matter how you break it down. You could have done 4 and 6, 3 and 8. Doesn't matter as long as we get all the way down to our common factors. And then remember that we have a negative 1 times that as well. So I'm going to put a 2 in my 2 column and a 2 in my 2 column. I still need to make a column for another 2 and another 3 and that negative 1. I also have 3 x's here. Now I have 8x, which is 4 times 2, and 2 times 2. 4 is 2 times 2 there. So we're just doing a factor tree there like we've done before. And now we list our factors in our columns. I have a 2, a 2, and a 2. 3 2's. 2, 2, 2, and 1x. Our common factors here, I have a 2, and a 2, and an x. So my greatest common factor is 4x. I take that greatest common factor, and that's the monomial that I factored out. I'm going to multiply by everything that's left then. If I look in my first row, all I have left that I haven't used are these 4 x's, so x to the 4th power. In my second row, I have negative 1 times 3 times 2, or negative 6, x squared. And in my last column, all I have left is a 2. And this right here is how I factor out a monomial. And that's part of the reason that it's helpful to list out our factors and do it that way, because then once we've gotten rid of our common factors, we can see what's left. I have x to the 4th power, negative 6x squared, and just a 2. We've already used those 3 columns. You can accomplish the same thing doing it by finding what's common. So here if I look 4, I can take a 4 out of everything, perfect. But then we're going to have to divide by 4, which doesn't seem so bad. But remember that we have to still have that accounted for. I can see I can take an x out of everything, so we're going to divide by an x. And again, that still needs to be accounted for. So a lot of times when people divide out what's common, they forget to put it in front. Don't make that mistake. Now, 4 divided by 4 is 1. Subtract your exponents, we get x to the 4th. I get negative 6, 24 divided by 4. Subtract our exponents, x squared. And 8 divided by 4 is 2, x divided by x, no more x's. So we get to the same place no matter which way we go. Here it was pretty easy because that 4 came out of everything, but if it doesn't, sometimes it takes a little bit longer to figure out what our pieces are. And this model over here gives us just a little bit better view of what we're doing. Feel free to pause here and give this a try if you'd like. 9 is 3 times 3. We're trying to write this in factored form, so we need to figure out what our greatest common factor is, factor that out, and then multiply by everything that's left. So I have 3 times 3, x to the 6th power, so 6x is there. 15 is 5 times 3. So I put a 3 in my 3 column and make a 5 column. X to the 4th means I fill 4 of my x columns. And 12 is 2 times 6, which is 2 times 3. A 3 in my 3 column, and then I make 2 columns. I also have x squared there. Now we compare. What do we have that's common in everything? Well, I have a 3, an x, and an x. So 3 times x, or 3, same base, add our exponents, x squared. In factored form, that means we're going to write it as 2 things multiplied together. So we have our monomial times, we're going to have a trinomial here. If we start with 3 terms, we're going to end with 3 terms inside our parentheses. So in my first row, that gives me my first term. I have a 3, x to the 4th power. I have a 5, x squared, and it's positive 5, so plus 5x squared. My last one, I just have a 4. So 3x squared times 3x to the 4th power plus 5x squared plus 4. Monomial times a trinomial. To check and see if we're right, guys, we would just redistribute and multiply. So I'd have 9x to the 6th power plus 15x to the 4th power plus 12x squared, which matches what we started with. So fairly easy to check these and see if you're on the right track. I'm going to stop this video here and continue on the rest of this section in the next one.